We are in the third lesson of SAT math class. So in today's class, I'm gonna divide our lessons, our topics into two half parts, which means like you're gonna watch the half of the video and the continuation will be just under this video. So specifically what we're gonna cover today is problem solving and data analysis. So in SAT, obviously, problem solving and data analysis is one of the four major domains. It focuses on using maths to analyze real-world situations and interpret and make decisions. So we are gonna talk a lot about statistics and things similar to this in today's class. Starting off with our agenda, as you can see, we've got a lot of things to cover. That's why I highly encourage everyone to watch this video fully without skipping any part, because I'm gonna be giving a lot of information in every part of this video. Starting off with percentage again. In percentage itself, we're gonna learn four things right now. First thing is percent, the interpretation of percent, what does it mean? And I'm gonna explain it here. It says percent means like hundreds of, or out of every 100 number. Let's say we've got one that's like it literally means 100%. It's like a 1 out of 100%. Now we want to cover a rate of change. We also have rate of change here, which we're going to cover later. We also will cover finding the part of solution of equation. Then lastly we'll cover word problems and mixture related to percentage. Before starting talking about these things, let us familiarize ourselves with simple basic terms, which are ratio and proportions. Why do we need this? We need this in order to deal with proportion types of questions similar to percentage. There are some examples which require us to go with the method of proportion instead of probably percentage way of solving them. So anyways, let us understand what does a ratio mean. Ratio is a comparison of two numbers. So there's a typo there. Is a comparison of two numbers. It's written in this form actually. So you are seeing just in this form, but just a moment. It is actually 2/3. This is our ratio. This is called ratio. What is it proportion? Proportions are two equal ratios. 2/3 equals to 4/6. But they are proportions. They are equal to each other. For now, these are basic stuff and this is enough to know. We will go in depth in the future with clear examples. Now it's time to cover percentage, specifically rate of change. First thing we're going to cover is this formula. This looks like, let me rewrite this, plus or minus p% over 100. Why do we need this? We need this if we want to find out by how many percent our initial value, which is x, increased. And what is the value of the new value? Let's try to look at an example there. It says this person has 130 in the bank account, which means its initial value. So write down instead of x. Then after 6 weeks of moving loans, his account is increased by 70%. It is important to pay attention to this part. By 70%, increase it. So since it says increase, we gotta add 70% over 100. This is just a very formal way of doing it, but for yourself, you don't necessarily have to divide by 100. You can get it all, do it in your head and get it as a 0.7, as a fraction, as a decimal. 1 is important all the time here. We all the time have to put 1 if we want to find out the rate of change in percentages. If we try to calculate, then it will be 1.7. Then if we multiply this, there is multiplication. If you multiply, we'll get 221. Our answer choice is C, which means that after 6 weeks, his account, if it increases by 70%, his money will be 221. This is how we solve these kind of equations. Now it's time to familiarize ourselves with another formula similar to this, which helps us to understand the rate of percent of change. For this, we've got this formula. We have to subtract original value from the new value and divide by original value multiplied by 100%. In simple terms, let's look at this example and understand it better. A company's revenue increased from $80 million in this year, which means it's old, to $92 million in this year. It is new. So based on this formula, what we have to do is to put into this formula. New is this value, which means 92, minus old value is 80, divided by 80. Multiplied by what? Multiplied by 100, based on this formula. What will simplify things, and if you calculate, we'll get answer is 15. You could also use the method of proportion, as we talked in previous slides. For proportion, let's get 100%, 100 is 100%, sorry, 80 is 100%, and what? 92 is x%, because we have to find this rate of change of it. If you cross multiply things, we'll get what? 92, basically 9,200 over 80. Oops. So basically, if you divide this, we'll get 150. Since our 100 initial value was 100 and increased by 15, then our answer again is 15. It's the way of solving it with the method of proportion. That's about it. Now it's time to familiarize yourself with the parting mixture types of questions in SAT. So this one they are actually pretty simple, regardless of these complex formulas. To find out, this is a question pattern, find x% of any given number. There must be any given number. This is the formula version of it. And this looks like this. This is how you solve it. So don't let it scare you, because it's actually simple in reality, in practice. So for example, let's read this example and understand better. A jacket costs $80. It is on a sale for 35% off. How much is the discount? As you can see, we just have to put it into this formula. So for 25, we put 25. How do I know it? Because it is in percent. X is in percent. That's why why we write it in this way, we want to get it in the form of decimal, but it's up to you. You may either prefer to put it 25%, then multiplied by this. But in calculator, you have to put percent. But if you don't like to deal with percent sign, then you have to convert in this form, into decimal form. Then multiplied by y, which is our initial value. If you do so, let me open our calculator for quickest. This is 20. We've got 20 as an answer. This is a discount. This how it is. This is how we solve finding the part type of question. Another thing that we have to know is mixture. Mixture has this formula, basic formula, that everyone must know in order to solve them. Let me try to explain this. Let's get A is a liter and C is a concentration. So A is liter, C is concentration. And imagine a scenario. Let me draw this. It's usually easy to understand with these pictures. It actually should be bigger than that, but since we don't have enough space, anyways. 10 liters and 20, okay, let's say, 20% of this is salt. We have also, what, 10 liters and 50% of it salt. Now, if we add them up, we have to add both liters and concentration as well. These are concentration. It is 20% of 10 liter. If we add them up, we'll get 20 liters and 70% of them are salt. This is basic principle of it. Now, in questions, in problems, they may be a little bit trickier than that. So let's read example for illustration. A chemist mixes 40% acid solution and 30% acid solution. How many liters of 40% solution must be added to produce 50 liters of a solution that is 36% acid? Okay, first thing what we have to do under exam condition, we have to straightly write down what we read, because we don't want to go and reread this and then think of writing them down. Straightly we have to write them out by understanding the core logic of it. First thing is we understood that we have to first write it down. Then the second thing, we have to understand the logic. Then after that, we can put in the numbers. So a chemist mixes a 40% acid solution. 40% of acid solution. Give question to yourself logically. 40% of what liters? How do we know? Since we don't know, first of all, we can convert it into decimal form. 40%, if you divide by 100, we'll get this. Of any acid solution, we don't know. Acid solutions. 40% of what we don't know, that's why we get it x, as we covered it there. Then we add it. Why we want to add it? Because Because their sum, based on this formula, their sum must be equal to 50 liters. We know their sum must be 50 liters. And it also says 30% of acid and other acid solutions of how many liters, we don't also know. But we know that their sum must be 50. In this way there is a way of writing them. We don't want to multiply it by x again. That's how most students do, but instead we have to write 50 minus x, then equalize it by 50 liters, 0.36%, let's say 36%. Now, why I wrote in this way, you might want to ask, because, let me show it. I wrote it in this way because these two will cancel and 50 equals to 50. Their sum must be equal to 50. Only in this way their sum equals to 50. This is just a small breakdown of the reason why I wrote in this way in the scope, in brackets basically. Now, we can either solve it manually or put it into Desmos, which I prefer, and which I'm going to show right now. Here it is. I put it into Desmos and wrote this equation exactly how it was written manually. And from the x-axis, we find out that our x equals to 30. So if we logically put 30 there, 30 liters there, and 30 liters there, 50 minus 30 is 20 liters for 30% acid solution and 30 liters for 40% acid solutions, and their sum equals to this. Since we are specified how many liters of the 40% acid solution is required, then it is 30. Moving on, we are now going to talk about statistics. So as I mentioned, we're gonna deal with statistics in many parts of this video, but in this slide specifically, we're gonna cover the core concept, the foundation of the statistics that we have to know. First of all, first thing that we have to know is mean. What does it mean, you might want to wonder. Exactly for you, I already wrote what is this. Mean equals to this. Mean is the sum of all values divided by the number of values. What does it mean? Let's get random numbers. 5, 3, 1, 4. 5, 3, 1, 4 if it's visible. Then, based on these description there, we have to add them all and divide it by their number. By their number is, but they are 1, 2, 3, and 4. There are 4 numbers, so we have to add this and divide it by 4. So we get 13 there, and 18 over 4. This is how it looks like. This is what is the median of this. Of course, it can be simplified, divided by 2 or something, but the core logic is the same. We add all given numbers and divide by their numbers in order to find their mean, or in other words, their average. It could be paraphrased also as average. Let me put just F. Now, another thing that we have to know here is median. What is it, median? Medians are middle value in the data set. Arranged by order, arranged in order. This part is important. For example, this cannot be, from here we cannot find median because it's not arranged in order. If we arrange it in order, then it would be approximately in this way. Of course, there is after 1 comes 2, but yeah, it's more or less in order. Now, if we want to find median of it, we have to find middle value of it. But in this case, we cannot find middle because there is no any middle number. For it to be middle, you may have another equation similar to this. And in this case, our median is 4. But in case, if we don't have this number and there is no middle term, then we have to add these 2 terms in the middle, 3 plus 4, and divide it by 2 in order to find their median. This is the median of these numbers. That's simple how it is. Now, third thing what we have to know here is mode. The mode is the value that appears most frequently. You can refer this as a trend. More people do the certain activity, it becomes as a trend. The same principle here. For example, let's say we have 3, 4, 7, 7, 8, 9, 11. Okay, let's say 12. So what is the mode of it? Again, I repeat myself, most frequently repeated number. From this data set, our mode is 7. Not their multiplication, not their sum, but only 1, 7. Their mode is 7. If you are asked to find out their mode, it is 7. That's it. This is the solution of this equation. Now it's time to familiarize ourselves with range. What is it, range? Range is the difference between the highest and smallest number. Pay attention to the order. For example, we have, I don't know, 4, 7, 8, 11, 87. Now, their range is the subtraction of the highest and smallest number. If we subtract these two numbers, we'll get 83. This is our range from this data set. Now, the last step is to find out what is it, standard deviation. In simple terms, I would say standard deviation is how spread out data around your mean. For this topic category specifically, I designed another next slide, which I'm gonna explain things further. Here it is, standard deviation. So we have three forms of standard deviation. First one is this graph, which our distribution is skewed to the right. This graph is skewed to the right. Second case is when our distribution, our graph is symmetrical. They are equal. This is equal from both sides. In third case is our graph is skewed to the left side. It helps us to interpret the data visually. We can either understand it visually or we can solve equations manually with this formula. Also, we can put it into Desmos, and since nowadays we have Desmos calculation, we don't necessarily have to remember this formula, but let me explain it anyways. Let's say we have two data sets. One data set is 3, 4, and 5. Then another data set is 4, 6, let's say 11. And question asks, which standard deviation is bigger? Let's say this is A, so which graph's standard deviation is bigger? To find out, we can put it into this form. So before this, we have to understand what is it x, m here, and n. X is our numbers, sorry. So for example, this is our x, this is also our x, this is also x1, x2, and x3. This goes till infinity, I don't know, depending on the question. M is the average of these all numbers. The first thing what we have to do is find average, which is our mean. M is mean, x our number, m is mean. From here, if we find out our average, we have to add them up, and divide by their number. Our mean will be 4, because their sum will be 12, and if we divide 12 by 3, we'll get 4. So this is our m, mean. We'll do the same with this example, just for the future. If we add them up, we'll get 10, 21. If you divide 21 by 3, we'll get what? We'll get 7. Our mean for this equation is 7. So now we have to put these numbers into this formula. Since we know our m and since we know our axis, all what we do, just put them into this formula. 3 minus, what was our m? Our m was 4, which is our mean. And we square this. And we do the same with 4 minus 4. And we square this. We do the same with 4 minus 5 from here. And we square this. Everything is under square. And we divide them all by n, by their number, 1, 2, 3, by 3. Because there are 3 numbers. So what we left is to calculate these things. We'll get minus 1. Minus 1 squared equals to 1. So 1 plus, this will be 0, plus this will be minus 1, and squared will be 1. And if we divide it by 3, this is all in square, we'll get 2 over 3 in square. So if we get this number from square, we'll get a certain number, which is not a whole number. Anyways, it can be simplified, but this is the way how we solve this equation. This is how we get this number. Now we want to do the same thing with this equation, and put it into this form and find out. Sorry, not 4 but 7, because our mean was 7 here. Plus 6 minus 7, oops, technical issue there, plus 11 minus 7. Oops, my bad. It's really hard to type these things here. In square, everything is under root. I have to erase some parts for this. Let me erase this part. See, I don't really like this. Oops, patience. Now, we have to calculate things. Let me do my calculations on my own. And we divide this by their number, which is 3 in squared. Now, important thing here is to realize which one is bigger, which one is smaller. For this, we can check it with the help of Desmos or calculator. Now, I put it into Desmos and we can see that these numbers equals to this first one and second one equals to this number. And it shows that this is bigger, which means standard deviation for the second one is bigger than the standard deviation in the first one. And the question will ask you the same thing which I asked initially. Which standard deviation is bigger in the two data sets shown? And you'll get, after these long calculations, you'll get your answer. Or you can go with another way, which is with the help of Desmos. Instead of learning this formula and typing things around, you can do it with the help of Desmos, which I'm going to show right now. For this, you open Desmos and you go functions there and find out standard deviation. This one. Pay attention, not this one, but this one. And you type the given equation. Let's say we have 3, 4, and 5 here. So, and 7. Now, again, we want to compare another standard deviation. Where is this standard deviation? With these kind of numbers. So you see that standard deviation in this one is bigger than this one, which means our answer would be standard deviation for this one is bigger than that. That's how we're solving with the help of Desmos. Now it's time to understand scatter plots in SAT. Scatter plot is a mathematical diagram represented by a set of dots that display the relationship between two numerical variables. Unlike x and y axis, scatter plots are not ordered and they don't basically follow the same principle. For example, let's understand here. Let's say we have X amount of certain clothes. X is clothes. And this one is probably their price. Y is their price. Y value shows their price. Let's say it is the clothes size. And it's their price. So it is, let's say it's 3. This one is 4, approximately 5. And it goes 7. It approximately shows that as the clothes size increases, their price also increases. For example, at this one, the price of the clothes, let's say, is $7. It is price. I don't know, at 5 size. This is how we understand scatter plots. And we have 3 types of scatter plots here, as you can see. First one is the positive slope, because it goes upwards, and the slope of it is positive. Because remember from our previous class, slope means just the rate of change. And we have negative slope, which our line goes down. And in third case, we don't have our slope, which means our slope isn't defined there. It is scattered. Now let's look at the example here. This is the example, and this question can ask in 2 different ways. Firstly, it can ask, line graph shows this basically, scatter plot shows this, and the best fit line is this this line is also described there, and it says based on this graph, how many values are more than the predicted line, or how many of them are less than that. If it says more, then we see that 1, 2, 3 points are more than this predicted line, and the answer choice would be 3. And another question from this could be arranged in this way. It says, based on the line of best fit, how many degrees does the high temperature increase when the low temperature increases by 1 degree? It's usually basically asking you what is the average change, rate of change, which means it is slope. We have to find out the slope of it. And to find out the slope, we have the formula of, where is my pen? So y1 minus y2 over x1 minus x2. Our y is this, and let's get our y is as a 90. Our first y is 90. So we subscribe, let's get this point, but it's not that clear. Let's get this point where our x is 60 and our y is at 75 approximately. And in this case, our x was about, so let's say roughly 70. But in this case, our x is 60. This is 10, this is 5, 15. If you divide 15 over 10, we will get what? 1.5. This is actually a little bit unclear to calculate it based on this, because answer choices are also very close to each other. And the reason why it looks like this and there is no answer choice, because we calculated very unclear numbers. It shouldn't be 75 there, for example, or it shouldn't be 70, but it should be 73 or 72. If you calculate it with precise numbers, let's say if we put 73 there, approximately, then if we put, instead of 60, 60 is correct, but 75 is also, yeah. Let's subtract 73. Let's calculate this by subtracting 73 from this equation and dividing these things. At the end, we get this number, and it could be rounded similar to what number? Similar to this number, because it could be rounded as 1.2, and our close option for this is this. Other than that, I mean, like, for precise answer, we have to see precise exact numbers in order to find their slope. But rarely you'll be given these kind of basically answer choices. They either look like different, not in this way, or you will be given different question type. That's it. I mean, like, for now, that's about it. That's how we solve this kind of equations. And this is our last thing that we learned today in this video. Now that's about it. Thanks for watching. From the next video, we're gonna cover other remaining topics like probabilities and what we left there in our agenda. Sampling, growth models, and others. That's about it. For now, take care.